So here we are to explain problem 2C. Calculate the amount of aluminium oxide formed in two different ways. Now, the first way would be to just simply use mole ratio like we have done in problem 2B. So let's quickly do that. Then we do need to have the MR value, so that's 2 times 27 plus 3 times 16 equals 2 times 27 plus 3 times 16, 102. So then we'll find that the 5.56 millimoles of aluminium, we need to divide that by 4, multiply that by 2, mole ratio, and we find divided by 4 times 2 equals 2.78 millimole of aluminium oxide. Now my pen stops working, so in pencil we continue. There's another way though, and this uses the law of conservation of mass. This law says that the total of the mass of the reagents needs to be equal to the total of the mass of the products. So if this is true, we should find that that the mass of the aluminium, plus the mass of the oxygen equals the mass of the aluminium oxide. Now I see that because my pen was ending, I didn't calculate the mass here, so I'm quickly going to do that. The 2.78 millimoles of aluminium oxide, we want to know how many milligrams that is, so that we multiply by the MR value and we find 2.78 millimoles times 102, we find 283 milligrams. So that was for, let's call this method 1 mole ratio. I hope you can see this because with the light it sort of reflects. Method 2, and this is also all shown in the elaborations. Method 2, law of conservation of mass. So let's see. For the mass of the aluminium that was given, that's 150 milligrams. The mass of the oxygen we had calculated in B, 133 milligrams. So that equals, I don't even need my calculator, that equals 283 milligrams of aluminium oxide. And let's check exactly the same number as we find with method 1 using the mole ratio. So these are the two methods you can use, and sometimes you find a mass of something and you know the mass of the reagents, and that's the way how you find the mass of the other product. So remember this trick, it might be useful someday. Thank you.